lot of interest, enthusiasm to learn among the faculty members, which is really appreciable. And it is my responsibility to make sure that your time is valued. So next 90 minutes, there will be a lot of key concepts I will talk about and also share various applications. So to make this program very, very effective and interactive, first of all, I request all of you, whichever place you're sitting, please hold a notebook and a pen, because that's very, very crucial. I'm sure all the professors in this group, they would tell the same thing to the students, that please keep making notes and be attentive. And that's also applicable when I listen or when you listen. So that's the first point. And make sure that note down many, many key learnings throughout. Okay, and I can guarantee you that it will be enjoyable learning experience. Okay, let me first start with the content and also maybe the ground rules first. So let me start with that. Okay, I hope my screen is visible. Can somebody confirm?
Yes,
Yes,
sir, it is
sir.
visible now.
Okay, thank you, thank you, thank you. First is 100% attention. And that's crucial, because when we listen little bit with multitasking, then what happens is we absorb very little, or our experience will not be good. So it's very important to cut off distraction. And today's world, the most distracting thing is mobile phone. I would suggest that please, if you're joined from mobile, of course you'll be watching, but if you're joined from laptop, then you will have to make sure that your mobile phone is kept upside down in a silent mode, so that you don't get distracted because of the notifications. And the third thing is make sure that you keep writing. And at the end, I would request some of you to ask questions and also maybe summarize some key learnings and all that. So let's make it participative, because virtual training is more difficult. First thing I'll talk about is about not about statistical one, about how to listen. This you can also tell the students. And how to listen when somebody is speaking. There are 4 parts you have to avoid. I'll talk about it. Then we'll get into how to apply the statistical tools. For that, the topic given to me is statistics for improvement, industrial processes, use cases. So this is the topic. So since I have to talk about use cases, I'll be talking more on application side. So I'll not talk about too much of a theoretical part of the statistical subject. I'm sure it has been covered in the past by some of the speakers. So I'll be speaking more on application side, but I will touch some portion of the theory. Some portion, not too much into theory. So how to identify a problem, how to identify improvement project, so that we can apply statistical tools, because everywhere statistical tool is not applicable. Some places it is applicable, some places it is not. So we will identify, we will understand the problems, types of problems, where the statistical tools can be used, such things as a basic and fundamentals. Then we'll get into use case, where we will see some box plot application, control chart 2x2 matrix application in industry, and measurement system analysis, test of hypothesis. I'm sure in this series of lecture, there may be discussion on various test of hypothesis, whether it is chi-square test or 2p test, or maybe one-way analysis of variance, or so on and so forth, even non-parametric tests, etc. So application is very, very important. And then how do we apply design of experiments? Can we see some application examples of a full factorial design of experiments? And if time permits, I'll also cover the case study of one more, but I'm doubtful that I'll be able to cover many case studies. One thing that I want all of you to remember: learning and not doing is not really learning. Learned and not applied is not really learned. In engineering college or in 12th, we have learned like differential equations, okay, partial differential equations, many such things. but I have not applied it. So that knowledge is gone. So that knowledge I'm not able to use now. So very important thing is the knowledge which we apply only remains. When we go to industry, till the education, we learn a lot of things. But when we go to industry, we have to take certain things and apply. And if the knowledge is not applied, it's waste. It's non-value added. That's why application of knowledge is really, really crucial. Just to begin with one something lighter side, one person, he was uh, on a fire balloon. He went in the air in the fire balloon, moving in the air, and he moved somewhere, and he was not knowing where he went. He was moving along with the wind and reached some place, and he looked at the downside, somebody walking there. He called that man, hello, hello. That man walking on the ground looked at this man, and the person in the fire balloon, hot air balloon, he asked that man walking on the street, can you tell me where I am? The person on the street looked at him and said, oh, you are in the hot air balloon. And the person on the hot air balloon looked at the man on the ground and he asked him, are you a mathematician? The person on the ground said, yes, how do you know? He said, your knowledge is perfect. What you said is perfect, and it is of no use to me. Sometimes people get perfect knowledge, but it's of no use unless you use that knowledge. So it's very, very important to learn application of whatever subjects that we learn. Because if we don't learn the application, if we are not applying it, then that knowledge is not of much interest. Just to give you a little bit brief about application of problem solving, we have been doing application of not only statistical, non-statistical, various tools. In each year at industry, the savings at my clients itself is more than 200 crore by using systematic problem solving, by doing improvement projects. Now how it is done? Very structured way. Some places we use statistical tools, some places we use other tools, but it's very, very important that we bring some change and bring improvement, because when we apply, we learn a lot. So that's why we have now about 2,500 case studies of application of various tools. Some 350 plus tools we apply at our client location in terms of problem solving. So the first point, whatever result that we get, the result could be in the personal life, or result could be in the company or in institution, wherever. These results are outcome of action. It depends on what we do. And what we do depends on the way we think. It depends on the way we think. Unless we change the way of thinking, what we do will not change. And unless we improve what we do, the result will not change. Very simple. Now, how do we improve the way we think? This depends on the input that we give to our mind. Because if I give a right input to my mind, then the output will be of good quality, right? But what happens today's world, people give various inputs to their mind. Input 1, input 2, input 3. So many different types of inputs people give. How? Because people think, oh, YouTube is free, I can watch. It's not free, it costs time. Now, efficiency is output by input. If I give input, and if I can't use it, then output is not there, only input is there. If I keep giving input and input and input and input, and if there is no output, then efficiency goes to zero. So if we want to become efficient, it is very important to give inputs which we can use. If I am in the training and consulting field, I must give input related to my training and consulting field. I must become expert in my field. Whether it's a total quality management or Six Sigma or problem solving, I must become expert and I have to give input so that I can use it in the industry and achieve result. So anybody who is, whichever profession we are into, it is very important that we must acquire skills related to our own profession or enhance the skills related to our own profession. And if we do that, it is wonderful gift that we can give to ourselves and also to the nation, because educational institution, they build the nation. And if they can create good students, that's a wealth for the country. That's why it's very important for people in the education field become extremely good, or the best in way, best possible way. They must be able to communicate, they must be able to inspire students to learn, apply, so that they can create wealth for the country. Now, coming to how to listen, there are four parts. Four parts. First part is called reverse part. Sometimes people attend. I was doing one program, and there are many participants from different places who came all the way traveling so much of distance. And one person was not even making notes, not listening with attention, simply sitting. Then I asked him, what happened? Why are you not attentive, or why are you not making notes? He said, actually, somebody else was supposed to go, but our HR department forced me to go to this training. Now, he's not willing to listen, not willing to learn. This type of part is called a reverse part. Reverse part means the person is not willing to listen. You put the water from the top or the bottom, water will not stay in the pot, because pot itself is reverse. It will not go inside the pot. So second part we must avoid is called leaky pot. It's a big problem today. This is called intermittent listening. Sometime listening, sometime not listening. Sometime paying attention, sometime not. There is a very good saying by Swami Vivekananda. He said, the difference between ordinary people and great people lies in degree of concentration. The difference between ordinary people and great people lies in the degree of concentration. If I am listening somebody, maybe initially my concentration level, for example, our human brain works at 110, 120 bits per second. Now, if I'm listening maybe 20 bits per second, 30 bits per second, after 10, 15 minutes, my concentration can go very high, maybe 60, 70 bits per second. That means I'm fully attentive, listening and making notes. And that's the state called flow state. And if anybody is in flow state, the concept of flow state is developed by Mihai Csikszentmihalyi, a psychologist. And at that state, we forget about time, we forget about ego, we forget about everything else. And we are doing our job and we are 100% concentrating. At that point of time, our happiness is very high, our productivity is very good, quality of work is very good. But it took 10 minutes to reach to flow state, but suddenly there is one message, I looked at it, deviated. Then distraction, my concentration level from 70 bits per second, it drops to 10 bits. Again, it takes time to reach to that level. So, hole in the pot will not allow the pot to fill full. So, whatever effort that or the trainer or the teacher or professor puts, but only little bit will remain because of the leaky pot. It's very important for the listener to avoid leaky pot, and best way is to make notes. The third part that we must avoid is called a dusty pot. Dusty pot means there's a predetermined mindset. For example, oh, whatever he's teaching is of no use, or it may not come in exam, it is not important, or I may have a preconceived notion. No, this teacher is not going to teach well. So these are all dusty pot. If there is a dust in the pot, then you put water, it is not drinkable. So it's important to have clean pot. And the last one is full pot. That means I already know everything. I don't have to learn. If the pot is full, you put whatever in the pot, it will not go inside the pot, it will overflow. So it's very important to avoid these four plots. And then we listen in any of the conference or seminar or the classroom, and then become good learner. Because it is important for each one of us to become a good learner. Professor Shoji Shiba said, to teach is word of arrogance, you can only create learning environment. How we can create environment where a learner is interested to learn. That is very, very important. It's not about how I teach, it's about how I make other person learn. Because if learner decides to learn, he can learn much more than what we teach. If he doesn't decide to learn, whatever we teach will not go to learner. So it's important to create good learners, and that's why it is very, very essential so that people avoid these kind of parts and stay focused. And there's an old saying that vidya dadati vinayam, true knowledge brings humility. Vinayat dhyati patratam, knowledge with humility, right? The person becomes worthy person. Patratva dhanam apnoti. That means the person who is worthy automatically will become wealthy. And dhana dharma tata sukham. The person who uses that wealth for good deeds will be joyful. So ultimately, with the knowledge, one can become wealthy and joyful both, right? Then by doing good things, of course. Let me get into the improvement related topics now. First of all, when we talk about statistical tools for problem solving or improvement projects, it's important to understand what do we mean by problem. Problem is a gap between where we are now and where we could be or where we should be, no matter how good we are now. Suppose I'm a student scoring 60% and I want to score 80%, that's a problem because there's a gap between. Suppose I'm student scoring 60% and I'm happy with 60%, there is no problem. Okay, so problem is the difference between where we are now and where we could be, or aspiration level, no matter how good we are right now. The person at 90% may feel that I have a problem, I want to score 95%. Same thing is applicable in the company. For example, there can be warranty, there can be rejection, there can be rework, there can be productivity, there can be attrition rate in the company. There are so many hundreds of key performance index or KPI or MOPs, measure of performance. It could be related to productivity, it could be related to quality, it could be related to breakdowns. So many parameters are there. And each and every parameter, there's a current level. And if company has aspiration to achieve higher level or the target level, then there's a problem. But the biggest problem is having no problem. That means one doesn't want to improve. If I'm 60%, I don't want to, I'm happy with 60%, then there is no problem. No problem. And then he doesn't want to improve. So biggest problem is having no problem. That's told by Taichi Ono. Once it so happened, one of the companies where I saw in the paint shop, rework was going on, and I asked the quality team that how much is the rework percentage? He said it's about 20% or 22%. So, oh, so much of rework? No, not so much. Our competitors are having 25%. Ours is 2022 is okay. No problem. So having no problem is the biggest problem of all. Sometimes people don't realize that there is a problem. And it's not only in the industry. If we look at all around us in day-to-day, with the eyes of seeing the problem, we can see many problems. And that's why Swami Vivekananda said, in a day when you don't come across any problem, you can be sure that you're traveling in the wrong path. For example, accidents. We are number one in the world. And every 3.6 or 3.7 minutes, one person dies in the road accident, fatal. And top number one is two-wheeler. Now, so many people die. It is more than any military attacks happening in the world. But so many people die on the road accident. It's a big problem. Now, if we're able to see this as a problem, then there's a possibility to do something about it. If we are not able to see this as a problem, then we say, okay, chalta hai. This much is fine. Right? That's why looking at the problem is also looking at opportunity for improvement. When it comes to statistical usage, we are not interested to demonstrate the use of statistics for the sake of usage. We want to use it to do some improvements, and improvement can happen when we find problems. And when there are problems, I see three kinds of managers in the industry. First manager, he asks who did it. Kisne kiya, bulao usko. Who did it? Which person? As per him, every problem is because of other departments. Every problem is because of others. This is one type of manager. He doesn't require any statistical tools, box plots, DOE, nothing is required. He can only blame, fire, all that. This is one type of manager. Of course, this program is not for them, but we must know that such kind of people are very much there in the industry. Second type of people are there. They also don't use statistics. What they do, the moment you give a problem, they say, oh, there's a new technology available. You pay 2 crore, you'll get this. Now there is no manual intervention, automatically it will be done. They will directly jump into action. I call this as atmospheric analysis. You know what is atmospheric analysis? Atmospheric analysis means analyzing in the air. हवा में analyze करना. Without going and seeing the current realities, without going and seeing practically what is happening, without collecting the data, without collecting facts, directly jumping to the action. This type of analysis is called atmospheric analysis. They also don't need statistical tools, problem solving tools, hypothesis. They don't need any of that. They just say, okay, this is there, do investment, do this investment, you'll get this. Third one, the kind of managers who has to apply tools and techniques for problem solving. And these are the people who will go to Gemba, actual workplace, will collect facts, will look at all the past data. They will analyze, they will stratify the past data, day-wise, shift-wise, operator-wise, supplier-wise, raw material-wise, variety of ways. They will stratify, they will analyze, they will experiment, they will make some changes and see, they will involve team, they'll come up with a variety of solutions, they will experiment the solution, and then they come up with proposed action and implement the action and check the benefits and standardize to sustain the results. They are the problem solvers. And all three kinds of people are there. It is very important to develop the third type of managers, who are the problem solvers. And when there is a problem, one thing that comes in the mind is people think that I can't do it. I can't do it. It is like saying that I can't win the match before even playing. So it is important to think I can. That's why Henry Ford said that if you think you can, you are right. And if you think you cannot, then also you are right. Because if you think you cannot, you'll find all the ways why you can't solve the problem. I will give you one example related to this practical example. One of my client, sometime I may share some case studies in the form of explanation. One of my client is Seat Tires. They won the Deming Award. They won the Deming Grand Prize. I'm sure you all know Seat Tires is a famous company. And 2008 or 9, one of my participant of PGDQM was supposed to do problem solving. I asked him which kind of project you will take for problem solving. He said, no, I'm searching for the project. Which is the biggest problem or pain problem for your company? He said that there's a problem of early failure of a tire. It's called new tire defective. And the defect is called TSS, tread shoulder separation. That means tire tread and shoulder get separated within 3 months. So customer is totally unhappy because of this. And our competitor is not having this problem. We have this problem and huge loss because of this. Then why don't you do it? No, I can't do it. It's very difficult. Even our R&D head and many people have tried and it's very difficult, very complicated. I can't do it. I said, then you must take this project because it is something, if you do it, it's very good for the company. He took the project. He took that project and then we applied the tool called paired comparison. Okay, this is based on Tukey's test. It is a part of Doreen Shanin's methodology, but we don't use the Shanin methodology. We use good bad analysis, Tukey's test. There's a book by Keiki Bhote on world-class manufacturing from that. So I told him that you collect 8 best tires and 8 worst tires and measure suspected parameters and send me. After a month, he measured and sent me the data for 84 suspected parameters. 84 parameters are there. 8 best tires, 8 worst tires, data he has sent. Best means didn't fail. Worst means failed within 3 months or early failure. And then with lot of difficulty they have measured this and sent. I did the analysis. Okay. Step 1, step 2. We have a counting. It's called, you arrange the data of Bob and Wow from smallest to largest. Look at the end count. There's a method. Okay. So I applied the method. Then I told out of this 84, these are the 4 parameter which is significant. You change from this parameter from here to here. You change this parameter from here to here, your problem will be solved. Then how do you say? I said, I'm not saying, your parts are saying, your data is saying. Why don't you experiment it? So he experimented. He sent with a new or changed spec, about 200 tires they sent, and no tire is failed. Then they made a change, design change, and that has given 1.3 crore saving. And it was the biggest success in terms of warranty reduction. Then I told him how to do this analysis. I said, okay, now I did the analysis for you, but now I'll teach you how to do the analysis of this kind of data. So it's very, very important. Thinking can is very, very important. I can share maybe 1 or 2 examples, industry application examples. Then I'll go to a little more deeper. When I joined Mahindra and Mahindra in the year 2006, Mahindra Igatpuri plant, which manufactures engines, and the plant head that time, Mr. KG Shenoy, who was a plant head, he sent a communication that he wants help in solving the problem of engines, specific fuel consumption. Fuel consumption is like mileage. Okay, more fuel consumption, less mileage. So SFC. I told I can help. Then people ask me, how can you help? You're not an engine expert. I said, I'm not an engine expert, but there are engine experts available. I can help on how to solve the problem using statistical tools, techniques, methods. Then they were curious. Then I went there. They have listed some 100+ parameters which can make influence on the mileage. In other words, fuel consumption of the engine. Then I suggested that you take engines, test in test bed 1, test bed 2, test bed 3. They have 7 test beds. They tested same engines in multiple test beds. Results were different. It is measurement system analysis. The cause was not in the engine. The cause was in the test bed. We just used the measurement system analysis range method, and their R&R percentage was extremely high. Then we came to know that engines are really good, not problem, but problem is with the test beds. Then which test bed? Why there is a test bed to test bed difference? Then it was easy to know which test bed is giving good results consistently, which test bed has variation in results. Analysis, and then they found some, in the testing there is some oil, the temperature of that varies in places, so that creates impact on the results. Then they corrected and the problem got solved. Just to give you some examples. So it is very, very important that we must learn how to apply these tools and techniques. Result is equal to skill into will. Suppose I have high skill. I know various statistical tools, hypothesis, design of experiments, so many things. Okay, or Shannon tools, so many things. But I'm not motivated to do good job. No result. If I'm not motivated, no result. Suppose I'm covering this topic. Suppose if my job is, I have to read out some slides for 90 minutes. If I'm not motivated, I cannot do good job. It's very important to have motivation or willingness to do good job. And only with the motivation one can't solve the problem. Also one must be skilled. So result is skill into will. Both are very essential to achieve results. What we need to learn from Japan is Initially, the statistical tools, right from control chart in 1920s, invented by Shewhart, various Americans like Dr. Deming, who made control chart popular. Then Ronald Fisher, R.A. Fisher developed design of experiments. Many of the original statistical concepts, it has come from Western side. But usage, very good use is done by Japanese. Because when Deming came to Japan, he told them to use the techniques, systematic method, and that is known as TQM now, total quality management. Let's look at the history of it. If people become good in usage of statistical techniques, problem solving improvements, how they can create wealth for the country. Because there is so much of waste, so much of non-value added, so many defects. Now, if I look at this particular case where there is a crisis in Japan after World War II, and the people are waiting for free food distribution. And Japan was known as a country making inferior quality goods because made in Japan that time, olden days, mera juta hai Japani, means not a good shoe. It's a fata hua juta hai. It's bad quality. That was the condition of Japan. People were poor. After World War II, their condition was not as good as Indians. Okay, just after World War II. But what happened in next 20 years? Really a miracle. By 1968, Japan became world's second largest economy. Till 2010, it was world's second largest economy. Now it is third largest. In fact, I was in Japan this year twice. One to present paper at Asian Network of Quality Congress. It's about 16 countries. There was a technical paper presentation. I'm fortunate to get a best paper award also. And it's a wonderful country to visit. And I have been going since long, and I've been working with Japanese from long. And very systematically, they use these tools and techniques in their country. When it comes to statistical application, I see that how they use it in the hospital to reduce the number of days of hospitalization of patient. That was one of the case which was presented last year, just before my presentation. So it's very interesting to see the application of these tools in Japan. So Japan, after World War II, they were in crisis. At that point of time, they had single vision of prosperity. Sometimes people take action and action and action without knowing where to reach. It is like catching a bus, getting down, catching another bus without knowing where to reach. People will reach somewhere. It is like, I did today's job, next day's job. Every day they are busy in doing that day's job. They don't know where they want to reach in 5 years' time or 10 years' time. If we work like this, if we don't know where we need to reach in 5 years' time, it means there is no vision. It is like catching the bus without knowing where to reach. Action without vision is waste of time. Action without vision is waste of time. Suppose I have vision, I need to reach there. But I don't know. I don't take any action. I want to reach there. I have a dream. Vision without action will remain as dream. Vision with action can change the world. So vision and action, both are extremely important. So Japanese had the vision of prosperity. For making it happen, they implemented a TEI, total employee involvement. Everybody involved in improvement. QC circles started using QC story, 7-step approach of problem solving, where they started using 7 QC tools, very simple ones, right? We all know those tools like check sheet, histogram, Pareto diagram, very simple, scatter diagram, stratification. They're all 7 part of 7 QC tools. Now, when they formed a QC circle in their own area, they started doing improvement systematically, going to actual place, collecting data, analyzing. That led to enormous improvement, significant improvement. Now, for example, if you look at the number of people involved, that time was about 1 crore people, about 10 million people. Okay, 10 million people doing improvement in their area, significant impact. If everybody does improvement in their own area, significant impact to the country. So many QC circles formed, and this QC circle training was given by Professor Karao Ishikawa. He's my guru's guru. I closely work with Professor Hitoshi Kume, and Hitoshi Kume has two prominent students. One is Professor Karao Ishikawa has two prominent students. One is Professor Kume, and another one is Professor Kano. Kano model, some of you might have heard. So I had opportunity to meet Kano also a number of times and attend his sessions. So many problem solving, kaizens, all this started in Japan, and statistical concepts. W. Edwards Deming, he brought the statistical concept from United States to Japan and told Japanese to use the tools starting from control chart, the basic things. That means, how do you distinguish common cause and special cause? Because if it's a special cause, you need to know at that point of time what happened. If it is a common cause variation, you need an improvement project. So where to use improvement project, where you have to only look at that particular data, why it is different. So this is started, and Dr. Deming made significant contribution. That's why there is an award in the name of Dr. Deming, or Deming Award, even today, right? And Dr. Juran also used various quality techniques. For example, today we call Pareto, which is one of the tools that we use in problem solving. But Wilfredo Pareto, Italian economist, developed this, but actually the person who used it for the industry is, or person who applied it is Joseph M. Juran. And Juran did a lot of work on quality improvement or productivity improvement, and Ishikawa, of course. So with all this, if we look at all these are like professors or people with lot of conceptual understanding who closely worked with industry. Now, just to give you one simple example of Professor Karao Ishikawa, I worked with Professor Washio, Professor Kume, various Japanese professors. One thing I noticed is Japanese professors, their connect with industry is extremely high, extremely high. They regularly visit industry. They will understand what is the situation there, what are the problems, what are the challenges. They regularly visit industry. The connection of the faculty and the industry is extremely high in Japan. So one thing which Professor Kano told in the program, Ishikawa used to ask Professor Kano that how is the QC circle, operators improvement circle doing? Is it good or bad? How they're doing in the industry? But Kano, being the person holding PhD, he was interested in using high-end statistical tools. But always Ishikawa used to ask that how about operators' involvement? He said it took 10 years for me to understand why such a basic things he's asking. He said after 10 years, he was in some other country where the operator at the final station in a company manufacturing refrigerator was cleaning the refrigerator with a dirty cloth. And Professor Kano asked, why are you cleaning with a dirty cloth? Operator says, this is a cloth given by my supervisor. He says, oh, your supervisor gave you dirty cloth? He said, no, he gave me clean cloth, but now it has become dirty after some time. I said, why don't you change it? He says, no, I am not authorized to change. Only supervisor can change it. Yes, why don't you go and tell supervisor? He says, why should I tell? If I tell, will I be paid more? Then it clicked in Professor Kano's mind. It is important to involve everybody in the journey of improvement. Otherwise, only management will think about, okay, we will do improvement, but that operator is not involved in doing improvement. That's why usage of basic statistical tools such as Pareto diagram or histogram, that is going up to operator level in the manufacturing industry. That's why 7QC tool is something which has to be implemented across and should be known even at basic level, at operator level. So this just to tell you that the basic things should be known to everybody. Then there will be some experts like green belt, black belt, such things. Now, coming to problems, there are two types of problems. One is a chronic problem, another is a sporadic problem. Now this we will distinguish by using control chart, and whenever there is a sporadic problem like the second one, the red dot what you can see there, it's a special cause, it is abnormality. That day, that shift, what happened? That's what we have to ask in problem solving. So whenever we collect data over a period of time, we must use control chart. If the process is having a stable process, that means there is no point going out of control limit, that process is called stable process, and stable process is the one where we really require Six Sigma green belt or a black belt or a project. If it is unstable, sporadic, we must use a daily management. That's a basic thing. And there is a specification limit and control limits. I'll not go into too much of theory because it's known to you. And specification limit is by design based on what is good and bad, and control limit is based on the voice of the process. This much variation is bound to come. Control limit, if it goes beyond control limit, you must ask what is the change in the process. If product goes beyond control specification limit, we reject or rework the product. So specification limit is to make decision about product. Control limit is to make decision about the process. That's why control limits and specification limits are not interchangeable. When it comes to problem solving, there are many approaches. Just do it, corrective actions, global 8 disciplines, QC, they're all practiced in industry. Whatever I mentioned, task achieving QC story, innovation approach, design for Six Sigma, all these are practiced in the industry. And there are different types of problems like chronic, sporadic. Cause is known or not known, solution is known or not known, execution is easy or difficult. Now it is important to have clarity which kind of approach we have to use. So after a little bit of 2-3 slides of theory, I'll get into the case studies. If we start any activity with confusion, amount of confusion increases exponentially as we proceed further. And if we start any activity with clarity, amount of clarity improves exponentially as we proceed further. Having clarity is important. For example, cause and solution is known. Dust on the part, because I can see that dust is generated there where some near the storage there is some person is doing some grinding and from polishing, and dust is generated, and that is accumulating on the part. Do I need a statistical tool? No, I can see it. Do I need a hypothesis testing? No, I can see it. I can correct it. Put a physical barrier, problem is solved. So these type of things, people should know where cause is exactly is known and solution is known. We just implement it. And cause known, solution is unknown. Here we need an innovation kind of approach. And cause is unknown and solution is known, implement the solution. So when cause is unknown, solution is known. Suppose I don't know why there is a dandruff, but somebody invented a shampoo, I can use it and problem is solved. I don't have to invent. Then if the cause and solution both are unknown, then we go for statistical tools, problem solving tools. That's the situation. Now, let me get into the project side straight away. I'll share 3 case studies so that we can look at the application.
Sir, can you repeat the statement, sir? The cause and solution, sir. The cause and solution, sir. Can you please, sir?
Yes, I will do that. So there are 4 situations where significant cause is known or unknown. Significant cause is known, solution is known, implement it. Suppose I know why it is happening exactly, the cause is known, solution is known, implement it. Suppose there is a road accident happening at one place, and that place there is some error, some divider is suddenly starting from there, and people are not able to see the divider, and they get collided, and the accident happens there regularly. Then cause is known, solution is known, change it. We can do correction there. Means we don't need statistical tools in such situations. So where cause is known but solution is unknown, here we need mind mapping. Here we need a innovative approach of like a task achieving QC story is there, or innovation methods are there, like TRIZ is there, 40 innovation principles, where cause is known but we don't have solution. Here comes the innovation plays a role. Not much into statistical side because it's more of finding the solution. Where cause is unknown but proven solution is already known. implement it. You don't have to find the cause. And cause and solution both are unknown. Like gear shifting is hard. I don't know why. Some products gear shifting is hard. Some products gear is okay. I don't know why. But there is a variation. When there is some variation like that, why there is a variation? I need a problem solving project. So I'll skip some of the concept part because I have to cover some cases. So practical cases, I'll skip these parts. I just want to know that, let me check in the chat. Have you learned or used box plot? Is it covered? Is it known? Can somebody answer me? Because I can't see the chat. Can somebody say? Is a box plot known?
Sir, a brief demo was given by one of the speakers during a session on other topic.
Okay. At least we are aware of the box plot. So good. So box plot is very, very simple and very useful tool. We have applied it in number of places where it's a tool where we can see the middle 50% of the variation as a box, and the median line and the tails are called whiskers, and there is an outlier. So it tells about center, it tells about shape, it tells about variation, it tells about outlier. So multiple things can be compared. It's one tool. So I'll not get into theory part of box plot. It will take a lot of time. I'm sure theory part, many of you may be knowing. Another thing is called a 2x2 matrix. I don't know whether this statistical tools, control charts, is it discussed? Can somebody tell?
No, sir. No, it was not discussed.
Not discussed. Okay. And the process capability, is it discussed? Process capability?
No, it was more of
No, sir. No, sir.
statistics or machine learning, DOE, etc. were covered.
Okay. So I will also show the DOE case study in that case. But a 2x2 matrix is something which is very, very useful. When I say 2x2 matrix means we have to see and collect the data whether the parameter is consistent or suddenly outliers are there. For example, from my home to go to the Bangalore bus stand, suppose, and if I take data for particular time, suppose morning 9 o'clock. So how much time it takes? Suppose it takes 48 minutes, 42 minutes, 47 minutes, 51 minutes. If it is consistent, it is predictable, it's called stable. But suddenly it goes outlier, suddenly one day it becomes something like that, it's unstable. So one thing to understand from the data is whether the state data is consistent or inconsistent. That means outliers are there or not. This is a basic thing that we can know by using control charts. Okay, so control charts will have control limits. If points go beyond control limit, it means it's a special cause or outlier or abnormality. Okay, it doesn't depend on the specification limit, irrespective of whatever is the specification limit. Suddenly one day it is different, outlier. Okay, so that day what is the change event? That needs to be analyzed separately. So if any parameter is having this kind of outliers, then we call the process itself is unstable. So another thing is whether the variation is larger than the spec limit or variation is more than the target. If variation is also more than the target, we call it is not capable. So how many parameters are not stable as well as not capable? How many parameters are stable but still not capable? That means there is no any abnormality, but we are not meeting the target. My variation is more than the target. That's the second situation. Situation 1 and situation 2. Situation 1, we have to do daily management. That day, what is the change event? And do the YY analysis and solve. Situation 2 requires problem solving because now the natural variation itself is more. Suppose from my home to the bus stand, it takes some day 30 minutes, some day 1 hour. The natural variation itself is high. Okay, then even though I will say, okay, you will reach home, my target to reach the bus stand is say 1 hour 10 minutes. I'm within the target. Every time I'm within the target. Even though I'm within the target, if I'm within the target, then I'm capable. Suppose my target is say 40 minutes, but my variation is more, consistently high. Then I will say it is, consistently high means no outlier, no special cause. Natural variation itself is more. In that case, I'm stable, but still I'm not meeting the target. This requires further analysis. I have to stratify the data day wise, time wise, which particular day it takes more time. I have to stratify, do the statistical tools, then come up with a different model for problem solving. This is a second situation where statistical tools are very, very useful. When it is stable but not capable, here we need statistical tools for problem solving. If I'm stable and capable, I don't have to worry, because this parameter, I am meeting the spec and I'm so consistent. Suppose if I'm unstable, but still I'm meeting the target, I still need to worry because some outliers are there. And that day, what is the change event I need to solve? So the situation number 2 really requires usage of statistical tools, where it is stable but not capable. That's where we need design of experiments. That's where we need various problem solving tools, because my natural variation itself is more. So in a company, when they were going for the Deming Award, this is a practical example. Okay, they tracked 821 KPIs. KPIs, key performance index. That means various measures. For example, OEE of a machine, overall equipment effectiveness of a machine, is one of the KPI, for example. Okay, or productivity is one of the KPI, for example. Now these KPIs are plotted like a control chart. After plotting, then they checked, is it consistent or suddenly outliers are there? If it is consistent, it is stable. Outliers are there, unstable. Then is it meeting the target? Not meeting the target. Based on these 4 situations, they plotted. And you can see Jan 16, Feb 16, March 16. This is the data, and how the green zone, the last one, is called stable and capable, that increased from 202 parameters or KPIs to 244 parameters. That means over a period of time in a company, more and more parameters are becoming predictable and also meeting target. So this is, but for that, 821 KPIs are, line chart is made, control limits are plotted, then capability, whether target is met or not checked, and then the summary is prepared. Then wherever it is stable but not capable, problem solving projects, Six Sigma projects, DOE projects are taken. Wherever it is not stable, then that day, what is the change event? Daily management to be done. So 2x2 matrix is something which will tell which KPI I need to do daily management, look at that specific data, which KPI I need to really do a problem solving projects or statistical tools and techniques. So, okay, box plot. Okay, another thing, I just want to know whether hypothesis testing, is it discussed? Test of hypothesis. I'm sure there are many people from.
Yes, sir.
Yeah, maybe
discussed the hypothesis testings.
Is discussed null and alternate hypothesis, because when it comes to hypothesis is assumption. For example, somebody may say that matching horoscope or kundli will create a successful marriage. Somebody says, no, it has nothing to do with that. Now, this is a hypothesis. So null hypothesis says that there is no difference between matching kundli or not matching kundli. Alternate says, no, there is a difference. So when such doubt is there, then it is important to collect data systematically and analyze. That's where the hypothesis testing comes into picture. So it can be done with the available data. It can be done by experimentation, by intentionally collecting control data. I'll share some examples how it is used. So we have a practical problem. We convert practical problem to statistical problem in terms of standard deviation, in terms of mu or proportion. Then we write null and alternate hypothesis. And then we decide which kind of a test to be used. Okay. For example, if I'm comparing variation, I will use variance test, 1 variance, 2 variance, equal variance. Or if I'm comparing average, I will use 1t, 2t, pat t, one way ANOVA. Or if I'm comparing proportion or percentages, 1p, 2p, chi-square. Or sometimes chi-square test for association, chi-square goodness of fit test. There are different tests. So there are rules which test to be used. So this analysis will tell me whether there is a significant difference among the group or not. There is no significant difference. So controlled batch and regular batch, whether there's a significant difference, for example, kundli matching and not matching, is there a significant difference? That's what it can tell by the test of hypothesis. Then I can check whether my assumption is valid or invalid. So for this, we use significance level, alpha level, p-value, or we may use a cutoff depending on what is the acceptable level. Like p-value less than 0.05, we say typically it is significant. There's significant difference like that at 95% confidence. And then from that, we make practical conclusion. Here are the examples of test of hypothesis. Okay. In one of the company, the parameter is called unbalanced value. When they rotate and check, the machine gives how much is the unbalanced value. Based on the unbalanced value, they have to either add the material or remove the material or do the rework of that component. Now, doubt is this unbalanced value, does it depend on the die to die variation? Now, I have data of products, multiple products coming from different dies, 4 different dies. Now I have die 1 data, die 2 data, die 3 data. Each die I have unbalanced value. When I compare, I can make a decision whether variation is high in any particular die, whether mean is high in any particular die in terms of unbalanced value. Then we can take action if there is a significant difference. And then we can deep dive why there is significant difference. Now, another example I can tell you, test of hypothesis. It's an actual case, contamination. And when it comes to contamination in the product, nowadays, whether it's in electronic component or maybe in automobile industry, the cleanliness is very, very crucial. Okay. For example, fuel injector. If you take fuel injector, if any contamination goes in the fuel injector, what is the consequence? The contamination will get stuck, and because of that, the fuel will not get injected sufficiently, and it will make impact on the vehicle, right, driving. Then finally, people say fuel injector failed. Now, fuel injector is failing because of contamination now, for example. Now, whether the contamination in the injector, is it because the incoming injector itself, the parts, incoming parts before I assemble, itself is having more contamination? Or when I'm assembling, whether more contamination is getting generated? Now, that's a doubt I have now, how to use the test of hypothesis. Because I doubt, somebody may say, incoming parts is having contamination. If you look at some companies like Bosch, Bosch is one of our clients. We regularly guide them, and cleanliness level is extremely high because they maintain class 8 cleanliness, which is very, very good level of cleanliness, especially in the plant where they make ECU, electronic control units, in Bangalore, in Nagnathpura. They have a big plant, and there, if you look at it, the cleanliness requirement is extremely high because of these kind of reasons. If electronic parts gets the dust, biggest enemy, it will create a lot of problems at later stage. So now the question is whether the incoming part itself is having the contamination, or whether contamination is getting accumulated when I am doing the assembly in my process. That's the question to be answered. So I need to test this hypothesis that incoming is a cause or not. I want to know. My null hypothesis says there is no difference in the incoming part. Alternate says there is, the cause is incoming. Then I can do intentionally pre-wash or pre-clean the incoming part. I will pre-clean for experimental purpose intentionally, and then I make sure that even if there is a contamination in the incoming part, that is removed. It may cost extra for my experimentation, but it's for experimentation. I'm not going to do every day. And I collect the data of that pre-cleaned part and I send it for assembly. And regular part, send it for assembly. Then I compare contamination percentage, millipore value. Is there a significant difference between these two? If there is significant difference, it means yes, incoming part has contamination. So when I clean it and send, I don't have problems. But if incoming part is not the cause and my process is creating contamination, even if I clean the incoming one and then send for assembly, still there is no improvement. It means the cause of the contamination is in my process. I can't blame the child part. Now, this is a practical example of how you can apply test of hypothesis in the industry. Okay. Another theory for the contamination is, for example, people open the door and close the door in the paint shop, for example. They keep coming and going. When they open and close the door, some dust can come inside the paint shop and the contamination may be there in the paint shop. Now, how to test this hypothesis? Is that a cause or that's not a cause? Experimentation. Then we experimented that, okay, let us not open the door for this particular shift. Only one break at that point of time. Once open, everybody goes out and immediately it is closed. Like in between, there is no opening. So it's experimental data. When experimental data is done, whether the contamination is high, regular contamination is high, or there is no difference, this kind of analysis will tell us by test of hypothesis whether that's a cause or not a cause. I'll show you some industry actual case studies of not of this one but different one. Another hypothesis testing example I'll tell you. In one of the companies, when they assemble the vehicle's windshield glass, front glass, windshield, when they assemble in the car, sometime it gets cracked. Now the question is it because of the incoming glass itself is having the problem, or is it my aperture on which I'm assembling or operator applying more pressure or something which is leading to the crack? That's the question. Now, how do I apply the hypothesis testing here? Now, when I say incoming part, I have two suppliers, supplier A, supplier B. And I think maybe there is a difference. If the incoming part variation is there, maybe it's different for one of the supplier. Now, the failure data is available supplier wise. Then I can compare supplier wise. Supplier A, 100 supplied, 5 cracked during assembly. Supplier B, 150 supplied, 20 cracked. Now, the difference is significant or not can be tested by using test of hypothesis. Such cases, available data we can test by using hypothesis testing. There are some examples of how you can use the test of hypothesis in industry. Now, I'll show you one case study. I will not show the solution part. This is from the sort center. You know, in Amazon, Flipkart, and all this, we click and we get the product. Oh, clicked, and 3 days you'll get the product. And you can see that the product is coming from far off. It's coming from Delhi, it is coming from Chennai, it is coming from so far off. And you can see where the product is right now. After 2 days also, you can check where is the product. This product travels along with many other products, and it goes to a place called sort center. And in sort center, it gets sorted. And each of the sort center, thousands of people are working. There are many contract laborers working in several sort centers across India. And the job of these people is to sort, like depending on they have to check the barcode and scan it, and suppose it has to go within the city, Bangalore, or outside Bangalore, Bangalore, outside Bangalore, Bangalore, outside Bangalore. I will just sort it out, because whatever has to go in the Bangalore will be further sorted within Bangalore, which place, so that it can be filled in one particular truck and sent. Now, thousands of people keep working in several sort centers across India. Now, how many products one is able to sort in a day? That's the productivity. And that will make impact on the cost of sorting. And cost of sorting is directly making impact on the overall cost. When we get the product from Amazon, there is a big transportation cost. We think that the product cost is so much, but there's a sorting, transportation, last mile delivery, person who is coming to our doorstep and handing over. All this cost is there. Okay, it's not free. For us, it looks it's free, but there's a cost involved. It's built in the cost, right? Now, this is an actual example of a sort center where the productivity is mapped. Okay, like Bombay, Kolkata, or different places, the productivity is mapped. When you look at the productivity, IXRU, where, I don't know, it's not working. Let me just check. Okay, now it's working. Okay. See, look at this one. This is at higher side. This is Ranchi. The productivity at Ranchi is quite high, whereas productivity at other place, for example, this place like Kolkata is very low, or this place is low, whereas this place Ranchi, it is high. Now, some place productivity is high, some place productivity is low. When I say productivity, how many one is sorting depending on number of people and number of products people sort. Now, box plot will give you one glance. You can know where it is high, where it is low. Then you can benchmark what is good in the place where it is high, why some places it is bad. Okay. Then they did a test of hypothesis. Okay, where they tested, okay, the standard deviations between two locations. Okay, where one is good, another is bad, and they compared the variation. There is a difference. One place productivity variation is high, another place productivity variation is low. Then they compared whether productivity is making impact on the cost, and there is a direct correlation. Okay, correlation between productivity and cost. More the productivity, lesser the cost. Okay, so cost of poor quality is significantly impacted by productivity. That is a correlation they established, and that is making impact on the gross margin, that is profitability of the company. So if the profitability of the company has to go up, then uh, you know productivity should go up. The correlation between that. Now this is the example where you can find that productivity at this particular place, IMR chart, was extremely low in October 21. Okay, then you can see slowly, gradually at December, it is climbed up, December 21, and it has gone up. And suddenly, sometime it once drops. Now, such kind of dropping suddenly is called sporadic or special cause. Now, when you plot the productivity like this, like IMR chart, you can know how the situation is. So productivity is is plotted day wise, month wise, morning, evening, night, and it shows that night productivity is lower than the morning. So, and again there is a variation, various comparison and analysis, and there are peak and without peak. When I say peak, for example, during Diwali offer, how much there is an increase in the sales, Amazon sales or Flipkart sales or various sales, no? It is 6 times, 6 times. That means the number of people, suppose required for sorting out is 1,000, now 6,000 people are required during that time, because so much movement, more trucks are required to transport the material. Okay, now there is a difference between peak time and non-peak time, so it is important to segregate. So stratification is very important. Okay, then this is the one-way ANOVA where the comparison is made in terms of productivity. You can see the last one at the bottom, that is Ranchi, which is highest in terms of the average productivity, and the first one is the lowest, and there is a significant difference between the productivity. Then the further analysis was done. I will not go into further analysis. One of the major cause for the productivity was absenteeism and attrition. And then they correlated that why there is an attrition, why people leave at one place more frequently, and why people continue at one place for more longer time. Then they have to define a strategy, how to retain people, because the person who is new, for his sorting speed is not high, but person who is experienced has got a higher sorting speed. By doing all the analysis and improvement in the productivity in the sort center, tangible benefit is 2.17 crore. Okay, for third party manpower cost saving. That's the benefit. So it is very important, but I have not shown that how much deep dive it is done. Few hundred, some 307 slides are there. Okay, only on this project. Each projects are like that. Some several hundreds of projects are there. So one case of using simple statistical tool. I think I'll be able to show one more case. There are many case studies, but I'll show you one more case of design of experiments, maybe. Yes. let me show one case and then we will end. I have many, but I don't have time to show all of them. So one case of design of experiments I'll show. This is very straightforward and simple, and I'll show end to end what is done. See, this paper is presented already, so I can share. Share this paper. Uh, this is There is a company in Pune, in Chakan, in Mahindra Supplier Park, and this particular company called Sharda Motors. 70% of the process is welding. Okay, and welding process, they're experts. They think they're experts, and they also call some European, and they to set the new process. What these people keep doing is one factor at a time: voltage, current, change one at a time, and then set it, and then okay, this is a weld parameter, and they run the process. This is what was happening actually. So this is a paper. So I'm just showing you the paper end to end. Then Mahindra and Mahindra, this paper is published, so I'm able to share this. So Mahindra and Mahindra has taken an initiative for various suppliers called Mahindra Supplier Evaluation Standard. And I was taking care of all this black belt project, green belt project, TOE projects that time, about 8-9 years ago. And there, these people were nominated for the design of experiments. And these people who came, they said, no, we don't need DOE. We are already setting the parameter, and our European person is coming and setting the parameters. Then I said, no, you are doing welding. It is compulsory to apply design of experiments to optimize your weld parameters. Then after they learned the techniques, first thing is to segregate the factors into 3 categories. So I'll show that. So there are different kinds of DOE, like full factorial, fractional factorial, response surface, Plackett-Berman, right, mixture DOE. So I have case studies for each of that. Okay, whether you talk about response surface or whether you talk about mixture DOE or Plackett-Berman, all sorts of DOEs case studies are there. Just to show you this one example, scroll it. These are all theory part. I'll skip this theory part. I'll straight away get into practical side. The first activity is called experimental planning. How do we plan this experiment? 85% of the success of the experiment is planning. Only 15% is conducting and statistical analysis. Planning is so crucial before we conduct the experiment. Sometimes people only learn about statistical tools and they don't learn how to really conduct the design of experiments. While planning, 3 factors we have to segregate, called experimental factor, control factor, and noise factor. I'll show you the actual case, how it is done. If you look at this particular situation of welding, current in ampere, voltage, and gas flow, drive speed, and stick out. Now, various such factors are there. Wherever it is written as E, the nature of factor is E. For example, current, they want to experiment 140 to 180 is a current status, and investigation region is 100 to 150. E means experimental. Okay. Now, voltage is also experimental. Gas flow is experimental. Drive speed is experimental. But below that, whatever you see is written as C. C means control. Control means they don't want to experiment it. They know it is going to make impact, so they want to keep it constant. They don't want to intentionally make change and study, because they already know that it is going to make impact. For example, if I put an unskilled operator for welding, it is going to create defects. I don't have to experiment intentionally putting unskilled and create a defect, because I already know about it. So I will not use an unskilled person, but I will write skill of the operator skill. I will write. During experimentation, I have to ensure that I put a skilled person. Otherwise, by mistake, somebody may use an unskilled person. So this is about experimental planning. And noise factor is something which I cannot control. I don't want to control, or not economical to control. After categorization of this, then in the Minitab, these 16 experiments are designed, 4 factor, 2 level, so 2 to the power of 4. So 16 experiments are designed in considering current, voltage, drive speed, and gas flow. And all the, of course, it's in the sequence in which experiment has to be conducted. And then what they have done, they have to do the setting for each of the factor as per the sequence there, and they did the setting. Now you look at the flow of conducting the experiment. First, they set the parameter like voltage, current, drive speed. They set the parameter, gas flow. These 4 parameters they set for experiment number 1. They make parts. Then after making part, they record variable response, all the measurable variable response. Inspector also checks the aesthetic part or weld part. Then they send it to test lab. Then they also do the destructive testing and generate all the reports. So each and every experiment parts are made, and then all the data is collected. That's what is been done. So experiment 1, experiment 2, experiment 3. After collecting this data, then the analysis of this data is done by using Minitab. Of course, I'm sure in the previous session you might have seen design of experiment is discussed. So we can use Minitab, or we can even manually calculate, but manual calculation is cumbersome, so we can use Minitab in that case. And here Pareto of standardized effects, and we see p value, which factor is significant. We make a residual plot, we make main effect plot, we make interaction plot, make contour plot, all this for each and every response. That means result. Okay, so here multiple responses are there, and we need to optimize the process considering multiple results or multiple Y's. Now let me show the case further. So individual response, for example, Pareto for one of the response called weld penetration. Now for weld penetration, when Pareto of standardized effect is made, it shows interaction effect of A and D, current and gas flow, is significant. That's what it shows. Likewise, for individual effect like weld penetration is one of the results or Y, then R square adjusted, these things are seen, and why there is an interaction is studied. Then residual plot is made. This is called 4-in-1 plot. I'll not get into theory, but this is a kind of analysis is been done. Then comes main effect plot. In the main effect plot, we can see that what happens when I increase the current from 100 to 150, what happens to my weld penetration is increasing from 35 to 55. When I increase the voltage 18 to 22, my penetration decreases. Drive speed 13 to 15, penetration increases. Gas flow 10 to 20, penetration decreases. This is about main effect. Now, it is important to know why it happens. It's not only just plotting the graph. Technically, when I do like that, why it happens? It's main effect plot. Then comes interaction plot. When you do the interaction plot, we can see that there is some interactions are also significant. And when the interactions are significant, you must also analyze why such a interaction is happening. What is happening when I change both gas flow and the drive speed together, or current and gas flow together? If I change current and gas flow together, what happens? Why there is a different result? This is the analysis part, technically analyzing the interaction plot. After analyzing these things, then it was required to do the optimization. So let me show the contour plot. Now this is a contour plot for weld penetration alone. Now this is a response optimizer for one factor. Now one response, not one factor, for 4 factors. Now let me show you the multi-response study. Now likewise, the company is not only interested in weld penetration. They're interested in weld penetration, weld wire consumption, throat height, power consumption, lug length, multiple things. When we do the multiple things together, and when we put a response optimization in Minitab, we can look at this white zone in the center, where the combination of this voltage and current in that zone will give you all the responses. You can get good weld penetration also, good weld wire consumption also, means lower side. Throat height also will be within the spec. Power consumption is also low. Everything you can get by maintaining the voltage and current in that particular band. Now this is optimizing for multiple responses, not only one responses. This is available in Minitab. So once that is done, then they will give a weightage for each of the response, how important each of the response is there, and then here we come up with a desirable model, mathematical model. Of course, it will give you what kind of setting is required for the voltage and current. Now, once they changed the process as per the new spec, what happened? Straight through ratio, first time right, 80% has become 98%. Weld penetration became consistent. Lug length became consistent. Throat height became consistent. Wire consumption, 14% reduction. Power consumption, 60% reduction. Gas consumption, 33% reduction. And because of that, it's not a big company, it's a small company. The particular plant saved 24 lakh, and group level, when they implement, it is 1.25 crore. This is the application of design of experiment. So I have many more such case studies. So just for the sake of time, I don't want to get into so many case studies. So now I'm open for questions, so that any practical application.
So can I ask a small question, sir?
Yes, please. Yes, please.
Sir, regarding the DOE, it is only for industry area, or we can do in any social science research, sir?
Oh, very good question. Suppose you want to experiment impact of people doing yoga on the health. You can do experimentation. Okay, I can tell you.
Can I share my topic? Maybe if you have input, I can show input, sir.
Yes, please. Yes, please.
So my research on a phishing thread among the students, sir. This is actually my topic, actually.
What is that?
Recently, the phishing scam in mobile banking. There are a number of scams available in mobile banking. So I just want to know phishing awareness and the social security behavior. This is what I want to measure, sir.
Okay. So in this case, you may not require design of experiments. So here it is important that we collect the data and then test the hypothesis. So test of hypothesis can be used here, and the data can be collected by creating a very clear survey form, questionnaire. And with that,
my percent, why I can't apply DOE? Because I just want the apply to be converted into a scoring, some scoring data, and apply to be practically. And I want to give the suggestion to the banking side, this to be implemented to minimize the scam in fraud in future. This is what I aim. That is why I'm asking.
Okay, very good question. I'll tell you. When I have one factor, impact of one factor on the result, okay. Then I use hypothesis testing. When I doubt the impact of two factors together or three factors together, joint effect.
Okay.
If I suspect there is a joint effect, then I can do design of experiments. Number one. Number two, design of experiments means I have to really experiment by intentionally making change. For example, I can run the fan speed more or less. I can experiment it. So if I want to experiment by intentionally making some change, then I can do design of experiments.
Okay.
Suppose I have choice. I have A and B, one choice. Again, A with one more thing and B with one more thing. I have another choice. Two choice together. Then I can use design of experiments by intentionally taking A with B or A with C, B with C. Like that, I can experiment. Then design of experiment is valid.
So I have framed the phishing awareness low, phishing awareness medium, phishing awareness high. This is what I fix the level, sir.
Yes. So what you can do is phishing awareness low, medium, high. Is there a significant difference in the result? What is the result?
Sure, security behavior, the social security behavior. Whether the awareness is more, the people are more secure and they are behaving in the mobile banking very safer.
Okay. How do you measure the awareness and how do you measure the behavior?
Yes, sir. I'm going to give the Google form and ask you to fill up the Google forms and what is the awareness, whether you're able to identify the phishing message or phishing calls. So based on the score, okay, you are very low in phishing awareness, you are middle, medium level or in the high level. So you'll be, how you going to stop the risk in banking areas?
Okay. One is awareness is my question here. Second, behavior,
Yes, sir.
phishing behavior.
Behavior, yes, sir, yeah, using mobile banking. How
No.
frequently you're using mobile banking?
Okay. Let me frame a question in a different way. There is a Y and X. Okay.
Okay.
Y is a
Yes, sir.
result or a response or an output which I want to improve,
Yes, sir.
and X is a factor or
Yes, sir.
cause which
Okay.
I can change. Now,
Oh,
Y is a response. Now, response is something which I have to measure as an outcome,
yes,
and
sir.
cause is something which I can set or change so that I can look at which is the optimum level of this particular cause so that I can achieve the required response. That's how it works actually.
Exactly. Yes, sir. Yes, sir. Yes, sir.
Right. Now, in this case, the question is, what is the response? What is the measurable response? Suppose if you have to measure whether my behavior on the mobile banking is a safe behavior or my behavior is unsafe,
Yes, 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 sir.
how to measure it? Again,
So I'm
based on
going
the
to
questionnaire.
yes, sir. I'm going to give the questionnaire and also based on that, what is the behavior? Whether they're going to, they find any phishing message in the email, they simply fit, or they're going to enter the mail, or they're going to pass on to somebody else. So the security behavior, whether they have gone into the message, or they leave the message, or they want to test the message. So the depends on the different behavior is available, sir. I'll plot the questionnaire, and based on the questionnaire, just giving marks now.
So here there is no experimentation. So it's
Oh,
collecting the data. There is no experimentation. There is no intentional
oh,
change. So I
okay,
don't
okay.
look at the application of design of experiments here.
Sir, can I have a question, sir?
Yes,
Yes.
please.
Thanks for the
Yes, sir.
session.
Thank you, sir. Thank you, sir.
Can you share the material that has been published?
I'll share the material.
And
Yes.
secondly, can you suggest some topics for our maybe PG students, UG students on these sort of projects? Because data collection, as you know, you are in industry, you are an consultant. So, but whereas students will not get access to data. So, can they refer to some online resources or some database and maybe do some small projects so that they will learn few things?
Okay. What I would recommend is that industry, if you are able to tie up with the industry, that's the ideal thing to do. That's the best thing to do. Because if the students and industry, if they come together, because if I get the data online or something, I'm not very sure. But if at all I can visit industry, my practical learning will be very high. And if we can get that access or maybe MOU with the company, and then we tell that our students will do project at your company and for this kind of project, then definitely there will be uh, win-win, because students will learn practical things, industry will get benefits based on the work done by students. So
Yes,
it
sir.
requires
Thank you.
collaboration. Yeah.
Yeah, thanks for that nice insights and suggestions. And also share some other material on DOE so that we get more insights on the practicalities. Thank you
Oh,
very much.
okay. So DOE, let me check what are the, if there are some soft copy books or something, I'll share
Yeah,
related
that
to.
can be shared offline to organizers, sir. Thank you
Yeah,
very much.
yeah. Thank you.
Sir, thank you for the wonderful session. Can you please complete the example which you started with impact of yoga on health and well-being?
Oh, okay. I was just trying to tell that if you want to know that, for example, by doing this particular yoga, this particular disease will come down. Then you have to experiment it. For example, uh, there are people who are not doing it, and there are people who are doing that. So to intentionally collect the people of particular age from particular place with that, for example, diabetic patients. So impact of this on the diabetic patient. So collect diabetic patients of those many numbers And there are other people also you are watching who are not part of this session. Suppose in our build, in our say society, there are 1,000 people. Say there are say 200 diabetic patients, for example. 100 diabetic patients will do this particular yoga, and another 100 will not do it. Means they will not do this kind of things. Now you compare whether there is a significant difference or not. Then it's a kind of a experimental hypothesis. Okay, that is one factor, because impact of yoga on this is kind of a experimental hypothesis. If you want to do design of experiments, then you will look for combination. For example, some people will do yoga and pranayam together. Some people will do, so you have a combination, so multiple combinations. So combination 1, combination 2, combination 3, combination 4. So different combinations you conduct. One batch with this combination, second batch with second combination, third batch with third combination. Now each of the batch, now you see the result, then you see which combination of that works well, then it is called design of experiment, more than one factor. I hope I
Yes, sir.
answered your query here.
Yes, sir. Yes, sir. Thank you.
Yeah.
Sir, I
Any
am
other
having one.
question? Yeah.
Yeah, sir, I am having one question.
Hmm.
So currently, I joined the new organization where we manufacturing the liquid silicone rubber molding. So it
Hmm.
means it's a mixture of two material. One is called A and second one is called B. So and
Hmm.
means in any kind of the injection molding means three major parameter will be there. One is your flow, one is your time, and the third one is the temperature. So with
Hmm.
respect to that, A and B, which will be influencing my parameter because of the viscosity perspective. So with respect to that, how can I will be
This is a
doing
good
the
case
DOE?
for this is a good case for DOE.
Yeah,
A
sir.
and B you are mixing, right?
Yeah, yeah, sir.
There is a tool called mixture DOE. Mixture DOE. You can make a note of it. When
Okay,
you
sir.
mix, I have a case study of injection molding with a mixture DOE actually.
Okay,
Okay.
sir.
And in one of the companies it is done because it was making impact on the rundown and other parameters when you change the viscosity of the paint.
Yeah, sir.
So mixture DOE means how much percentage, for example, thinner, hardener, paint. Three things to be mixed. What proportion hardener, thinner, and paint should be mixed? So there are
Okay.
different proportions possible.
Yeah, sir.
Plus, there can be process parameters also along with that.
Yeah,
So
sir.
jointly, if you want to analyze, then
Mm.
mixture DOE is a kind of a design of experiments which you can apply.
Okay, okay, sir.
Okay.
Thank you so much. And
Thank
sir,
you.
will it be fine that you can share certain glimpse of this particular DOE which you already been conducted? So if it's possible to horizontal deploy me at my organization, then it will be fine for me.
Let me check if I can take a example of mixture DOE. Just a second.
Yes,
Check.
please.
Okay, I'll quickly. I'll just show you one example of DOE in the paint shop. Okay. Now this is an example of uh, to reduce the thinner attack. That's one of the problem. Hardener and
Sir, the
thinner.
screen is not shared.
Not shared.
Yeah,
Uh, is it there now?
it's
Hello.
coming up. Yeah, it's there.
It's there. Okay. Thank you. So here the mixture DOE is been done. Hardener, thinner, and then the design is there for both upper portion and lower portion is defined, like A is 160 to 170 and B is 430 to 440, and then they did the experimentation with hardener and thinner, and then experiment is done and R square is very high, and these are all like results, and then these are all the combinations where hardener and thinner the best combination is achieved. Okay, and it has given good results in terms of reducing the thinner attack. So thinner attack quantity 0. Afterwards, they tried for the 40 products. Okay, like hinge cover, diamond white, different color fender, and it's not creating a thinner attack. So they tried with earlier 7,787 samples. 403 products used to have thinner effect, a thinner attack. Now 5,687 samples, only 2 samples got a thinner attack problem after optimization. So the test of hypothesis shows that there is significant reduction. Okay, so this is one example.
Okay, thank you, sir.
Uh, okay. Okay, I know it's time up and people must be waiting to log off. Before you log
Hello.
off, hello?
Yes, sir. Yes, sir. Please go ahead.
Yeah, before you log off, there is some surprise from my side. Thanks to Sagar ji for introducing me. I have been also a past president of Indian Society for Quality Pune chapter. And there is one surprise, which I said that it's really a surprise. Even though I'm into training and consulting for so many years, I have one passion or hobby, that is performing magic. And this I have been doing from childhood 4th standards. I have performed in television and international level. I have performed. So naturally, I will end with one magic, and then you can. I'm sure you will not miss this because it's something interesting part. Okay. Uh, I hope maybe if you can make my screen as a full screen or a spotlight or something. Am I visible on a full screen for you?
Yeah, we can change, sir. We can pin your.
Oh, you
Screen.
can pin. Okay, if you can make. Okay, maybe let me stand a little far so that this even. Okay, I hope this rope is visible.
Yes,
Yes,
Yes.
sir,
Okay.
visible.
it is visible.
Okay, so I have a rope and I
Yes,
want
sir.
to tie knot between 2 ends of the rope in the world's fastest way. I'll hold one end in the right hand, other end in the left hand, and then I tie a knot, and this knot is called the world's fastest knot. So here I have knot number 1 and knot number 2. The world's fastest way to tie knot between 2 ends of the rope. And if you're not happy with 2 ends, I have one more end. This is the 3rd end of the rope. Now I have 1, 2, and 3 ends. And one rope can't have 3 ends. You're still not happy. I have one more end. This is called 4th end of the rope. Now I have 4 ends. 1, 2, 3, 4 ends. 4 ends means there has to be 2 ropes, and I have got 2 ropes of exactly same length. Right? I have 2 ropes of exactly same length. But before presenting this magic, how many ropes I was having? I was having only 1 rope. So what you're all seeing is just an illusion. Actually, I'm having only 1 rope. Right? So you've seen rope with 2 ends, 3 ends, 4 ends. Now what I will do is I'll just take these 2 ends together and I will tie one simple knot. And I'll tie one more knot. And what you can see now is a rope with 2 knots. If I blow this knot, let's see what happens. I'll just blow the knot. And this is rope without ends. Now the knot has fallen down and I have rope without ends. Let me take up this knot here, which has fallen, and I will open this. I'll open this. Don't lose your concentration. Don't blink your eyes. If you blink, you'll miss wonder. I'm going to place the small piece of rope on the main rope like this very slowly. The small piece of rope is there. Very slowly, I'm placing on the main rope like this. The small piece of rope is there on the main rope. It becomes soft, 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 and slowly it gets linked to the main rope, and I'll get back the original rope again. Right? So you've seen rope with 2 ends, 3 ends, 4 ends, without ends. If you want to cut the rope into 2 parts, I don't have scissor. I'll just use these 2 fingers, cut the rope, and again I have got 2 ropes of almost the same length. But before presenting this magic, I was having only 1 rope. How to make 2 ropes into 1 rope? Very simple. I just have to twist my hands and untwist. It's so easy to make 2 ropes into 1 rope. Now again I have got only 1 rope. And here there are ends, here the middle. I take ends in the right hand, keep middle in my left hand, and I place ends in my pocket and middle in my left hand. and then I make this ends invisible and bring it here, and I get ends here, and here I get the middle. Now, some of you may think that this is not a normal rope or this is a special rope. One way is to visually check, and another way is to check like this. Is there a magnet or something like that? And in my uh, physical programs, I throw the rope to the people so that they can practically check. Here I can't do it. It's a virtual program, right? And the last saying, I would like to thank a team of VIT for giving this wonderful opportunity for me to share a few things in a short period of time. And I hope I could add some value to all of your time. Thanks. And one Subhashita I will tell before I end, I think, which is apt when it comes to the application. There is an old saying which says, Ajnebhyo Granthina Shrestha. The person who has not read the text, compared to him, person who has read the text, he is in the better position. Grantibhyo Dharino Varaha. That means the person who has not only read the text, he remembers what he read. He is in the better position. And Dharibhyo Jnanina Shrestha. Person who has not just memorized the text, he also knows the meaning out of it. He knows what is the knowledge behind it. Then he is a superior. He is a better than that person. And lastly, Jnanibhyo Vyavasayinaha. Person who puts the knowledge into practice, he is superior of all. So it's very important to put our knowledge, whatever we gain, into a practice. Thank you all for this wonderful opportunity. Thank you.
So it was a very
Thank you,
mind-blowing
sir.
session, sir. So two
Sagar
words
sir,
is gone
please
like
go
anything, sir.
ahead. Sagar sir, please go ahead.
Uh,
Yeah.
Dear
Can you tell me the
participants,
phone
we
number
will
and mail,
stop
sir?
here question and answer. Yes, sir. We will share Mahesh sir's phone number, the email ID to you, to everyone. So you can ask your question via email, and we will answer it. So we will stop here. Thank you, sir. Thank you, Mahesh sir, for such a wonderful, nice session and such a lovely magic. Thank you once again. And now I hand over to Professor Bilin Kamble, sir.
Mahesh sir, thank you so much for honoring our request, and the session was indeed beautiful. I'm so sorry I am unable